All right, hi, this video is going to be on the similarity for section 7.2. So similarity is when two shapes are the same number of sides. So triangle to triangle, quadrilateral to quadrilateral, but they're not necessarily the same shape. So they're same shape. Okay, when this happens, so it's like taking a picture on your phone and increasing the size or decreasing the size of it, or on the computer. You keep the angles are the same. So the angles will remain the same degree measure. But the sides are what's going to change. So the sides are going to be in ratios. So the sides will be in ratios. So they're going to be bigger or smaller, and that's where cross multiplying will come in handy and that sort of stuff. So when you see some similarity, it's going to have this symbol in it. So the symbol, like, it looks like a congruent symbol. So that means similarity, similar. So on this, it's going to be very much like congruent. So we are going to follow the order of the letters all the time. No matter if the picture is used, the order of the letters is more important than the picture is. So this first thing I gave you, I didn't include a picture at all because we don't need one. So we use the order of the letters, and I said triangle ABC is similar to triangle MQT. So this means usually, but it doesn't mean always, but usually one of them is smaller or bigger than the other. So I'm not going to draw it, but what I'm going to ask is first, identify, so this means that you have angles that are congruent. So when I'm asking for the angles here, I'm saying which ones are congruent to each other. So we're following the order of the letters. So the first letter, so angle A, so if I were to draw it, angle A would be equal or congruent to the first letter over here is angle M. Okay, and then you follow the next one. So in the middle, angle B is going to be congruent to the middle angle here, which is angle Q. And then the last letter C, or the last angle here, C, would be congruent to angle T. Now, I don't know the degree measure of these, and I don't need to. I just know that they would be equal. So that's very similar to congruence. Now, the sides are what changes. So before, when we do congruent, we would say side AB is equal to side MQ. Well, we're still using the order of the letters, but we're not saying they're equal this time. So what we're going to do is set them in ratios or in fractions. So we would say side AB would be compared to MQ. Now, since they're in ratios, we would just say this is going to equal another pair, and I just go down the line. So I do side BC, so side BC would be in a fraction or compared to side QT. And then the third side would be A and C. Would be compared to side MT. Okay. So this is a lot of what we're going to do in this unit. We're going to do this and compare the information. So, and then you're given these for similarity. You're given them, and they're sometimes in just statements. These are called the similarity statement. And so the next one I'm going to give you is actually both. It has the picture and it has the diagram in it. Now, please do not follow the diagram. Follow the statement. Because what RST, well, this is not set up in the same way. So RST and DEF, they're kind of like mirror images of each other. But follow the order of the letters. So Angle R would be the same or equal to angle D. Angle S would be the same or equal to the middle letter at E. Angle T would be the same or equal to angle F. Now, on the side, same thing. We just want to follow the order of the letter. So RS not equal to, but in a fraction or compared to DE. And then ST would be in a fraction to EF. And then RT would be compared with DF. Now, the one thing you can do is you can say, okay, if I'm doing RST, so I'm starting here and I'm going this direction. So I know I start here, so this would be first, middle, last. You could do this on this side, do first to middle to last. So I know here are these first two, these middle two, and the last two. Now, to get numbers involved, they're going to ask you what a scale factor is. Now, a scale factor does not have anything to do with the angles, because the angles we know, they have pairs that are equal. The angle scale factor has to do with the sides. So, first of all, what I would do is say, okay, I have some numbers here. So I have NEW and FOG. So I'm going to do a thing like I did here with the sides. I know that NE is going to be compared with FO, because the first two and the first two. The middle two with EW would be compared with OG. And then the last two would be NW with FG. Once I get that done, all I'm going to do is take wherever I have numbers, I'm going to plug where the numbers I have, I'm going to plug them in. So I have this number at NE is 3, so NE would be on the top here. Now, do I have FO? Oh, I do have FO. Okay, so FO is here. Now I'm going to look at the other fractions too. EW, I do have EW here at 6, so I'm going to plug that in. You know what, I switched some letters before I did this, so let's make this 28 now. Here, I'm going to put it here. I had switched the letters and not the numbers. So I'm going to leave the 6 here. The OG, I don't know, so I'm going to leave that blank. No, I don't know what it is. NW, I don't know, because there's a blank over here, so I'm going to leave it alone. So NW blank and FG is here at 28. Now, I'm not going to cross multiply and do that sort of stuff. I'm just looking for a scale factor. So I'm just looking for one of these to have a fraction in it, and I do. I have the number top and bottom in that first one. So that's the only one I'm going to focus on. I'm going to ignore the everything else. Now the scale factor is the comparison of these numbers. So it's 3 to 21. Reduced, that would be 1 over 7. So the scale factor, this is the scale factor right here. That's all you're looking for. So comparison, what two sides can I have compare? Where are their numbers to compare them? So this is, so either 3 over 21 is my scale factor or 1 to 7. So it means however long one is, the other one is 7 times bigger. Now, the same thing can happen when you don't have triangles. Now I have a 4-sided shape and a 4-sided shape. One is definitely bigger than the other. In the middle here, I did tell you there is a relationship between them. So RSTW is similar to QPXY. All right, so same thing. I'm going to have RS first 2 over QP. And then I have S to T compares with P to X. T to W compares with X to Y, and R to W compares with Q to Y. Okay, so I need to find one of these fractions, the scale factor. I need to find one of these fractions where I have the top number and the bottom number. So I'm going to do it this way this time. RS I do have is 2, so I'm going to just put it there. QP, oh awesome, I do have that one too, so that's 12. Let's just check the other ones real quick. ST I have here at 4. PX I don't have, so so when I don't have it and I'm doing a scale factor, that doesn't help me at all, so I'm going to get rid of it. TW I have here at 3, but XY, oh I do have here at 20. Oh boy, I messed this up again. Jeezy Pete's. Pretend that's not here, put 20 here. Jeez. All right, so I have 3 here, but I have nothing here now. This will not be like this on the test, by the way. RW, I've already checked them. RW is here, nothing, and QY is here. Yeah, 20. So there was one fraction where you had the 2 numbers. That's what we're looking for, is which fraction it is and what 2 numbers are we for sure that we can compare. Make sure you use the order of numbers. All right, so 2 to 12 or 1 to 6. Now, there's a thing we can do without comparing, without doing a calculation. It's going to ask you the ratio of the perimeters and the ratio of the areas, or it's going to ask you for one of them. The ratio of the perimeters is exactly the same as this. So 1 to 6. So the scale factor and the perimeters are the same exact ratio. If you wrote 2 to 12 here, that's also fine. The ratio of the areas is where it changes. You're going to use that same scale factor, but all you're going to do is square the numbers because we're actually multiplying stuff. That changes the scale factors differently than the perimeters when you add them. So all you would do is take 1 over 6 and square the top and square the bottom. So it'd be 1 over 36. Okay. If you had a different problem which said the scale factor was 2 to 5, I asked you for the ratio of the perimeter, you'd take it would be the same exact ratio. The area ratio, again, you just take the 2 numbers and square them, so 4 over 25. That's all you're doing. All right, so last couple of things here is asking if the shapes are similar. So now you see you don't have the order of the letters to follow. So what you do is you start with one triangle and list the orders I would do from like smallest to largest. So just put them in a list, like 8, 10, and 12. Now we're going to put these in fractions with the other triangle, but I have to put the smallest number in this triangle under the smallest number here. So when I look at this one, 24 is my smallest, so that compares with the smallest side. So it's kind of like making another row in order, so 24, and then 30 is next bigger, and then 36 is the biggest. When I compare, I need to make sure I do the smallest number to the smallest number, middle number, biggest number, biggest number. What happens now is we take a calculator and we either divide the top and bottom or we reduce the fraction to make sure they're all the same. So 8 and 24 is 1 to 3, 10 to 30 is 1 to 3, 12 to 36 is 1 to 3. If you divided them, you would get 0.3 repeating. Either way, if it's a fraction or a decimal, they have to be exactly the same. So the shape's similar, yes. Sides are in equal ratios. That's all you're looking for. So the next one you can do with a different shape. You can do it with rectangles. Now the rectangle, I only have 2 numbers here because we know opposite sides are the same, so I don't need to repeat that number. So when I do this, again, I compare this. So I write this one rectangle, I write the number from smallest to largest, so I only have 2 numbers. Now I make a fraction with the other ones, and I say, okay, the smaller number goes under the 5, the bigger number goes under here. Now we reduce or divide them, so this 5 over 2 stays 5 over 2, 3 over 10 becomes 3 to 1. If you did a decimal, did top and bottom, 5 over 2 is 2.5. 3 over 10 is 3. Either way, the decimal or the fraction, they are not the same. So these are not similar. Why not? They are not equal ratios. So you're looking, you have to compare all the sides here. Now rectangle, you only have to compare the smaller and the bigger. And triangles, you need to compare all 3. Last couple things here is going back to these letters and using the statement and just filling in which ones go together. So this first one I have T to A, so middle last goes with middle last. So fill in the blank here. RN would go with person last, so SA. Now the same thing here. I have S to T, first 2. Well, automatically that has to go with the first 2. RM. Okay, and then last thing here is write a similarity statement. Now, because you're not always given all the information, you just want to go from like shorter sides to the bigger sides. So I would say put triangle. What do we have? I'm going to label one triangle first, BAC. I'm going to put similar, and then I'm going to go TRP. Let me know if you have questions. Thanks. Bye.